Hello, I am Pavitra. I would like to explain the complete structure program regarding a sliding gate automation system that I have developed. Currently, the most opted type of gates are automatic sliding gates. People prefer this kind of gates since it does not require any kind of manual operation and can be operated automatically with a push button. This system requires a program to let the user automatically open or close the gate using a remote control. This remote control will act as a switch to enable the operation of motor that will move the gate. Switch 2 and switch 3 will act as limits to give input that the gate is either fully open or closed. The IR sensor will detect any obstacle in the path of gate and halts the operation until the obstacle is removed. And now, let's have a look on our schematic diagram and flowchart of the automatic slide gate system. This schematic diagram of automatic sliding gate system was developed using freezing software. This helped us to identify the connection between the components and Raspberry Pi Pico before proceeding the hardware test. Moreover, the flowchart of the circuit is drawn using flowchart maker software. This flowchart mainly represents the interaction between the user and the system. The process of how the system is responding to the user activities and the whole functionality of the system is represented in the following flowchart diagram. This flowchart also shows the flow of activities done by the system and the user. The flowchart is helped to visualize the required steps, which is especially useful when managing a project. Each diagram includes actions, who is responsible for executing those actions, and the inputs for each step. Then this is my simple programming code that I structured for this assignment. The programming code is wrote in MicroPython using Tony software. This represents code block of function for the Raspberry Pi Pico to execute this task. For this program, I mainly use if-else statement to create a multiple condition when receiving the input from user. Now, let me demonstrate how the system works. As default, the gate will be in off mode. The operation of opening the gate begins when the push button 1 is pressed. While the gate is opening, the green LED will blink until the gate reaches switch 2. When the gate reaches switch 2, the green LED stops blinking and remains on to indicate the gate is fully open. Then, the push button 1 is pressed again to close the gate. During the closing operation, the green LED is turned off while the red LED starts blinking. When the gate reaches switch 3, the red LED stops blinking and remains to light up. During the closing operation, if any obstacles are detected in the path of the gate is automatically stopped and orange LED lights up. When the obstacle is removed, the gate continues to close. Hence, the yellow LED will be replaced by blinking red LED until the gate reaches the limit switch 3. And finally, through this project, we gain knowledge of the fundamentals of Raspberry Pi Pico, interface programming, and the use of the MicroPython programming language. We also learn about the built-in GPIO pin, which can be used to link the Raspberry Pi Pico to additional parts like LEDs, push button, and IR sensor to monitor the appropriate program output. We were able to construct the schematics for the circuit using the freezing software to show how the components were connected. This system flowchart is created using the Draw Input Output program, which facilitates a better understanding of the program's workflow and helps prevent error during program execution. In order to use the IR sensor module in this project, we also learn how the function works. As a conclusion, the automated gate system is very useful and used widely at homes in Malaysia. While being convenient, the automated gate systems also offer safety features with the help of sensor. That's all from me. Thank you.